Hi, it's Mr. Baker here with another physics video. Today we're going to be looking at refraction. Okay, so today's lesson is all about refraction. And we're going to be answering this question today. Why should a non-swimmer be careful about jumping into a pool of water that looks shallow? So what's going on here then? Well, this is refraction. So the light is travelling through the water. So the light is travelling at one speed through the air, and it's travelling at a different speed through the water. And because of that, the light is refracted. It's changing direction as it's going through the water and back out again, and so the pencil appears like it's broken. If we had our light ray on like that, so that's a ray of light, like a laser beam or something like that, if we were to zoom in on that and look at it like this, then we might be able to see where the sort of the peaks and the troughs, if you can remember to how light is. Light is a series of peaks and troughs of light, this transverse light that's coming from our laser beam. So say the dark bits might be a trough and the red bits might be a peak, and it's going along like that. And you can see what's happening is that the light's coming out through the air, and you can see that these peaks, so the distance between one red and the next red is longer than when it's here. So the wavelength here is longer than the wavelength here. And refraction is all to do with the changing in direction of light as it goes from one material to another material. And it does that because through air or through a vacuum, the light can travel slightly faster than if it's going through material like water or glass or diamond or some other material like that. And when it does that, at the boundary where the light actually hits, you can see this difference here very slightly. You can see that on this edge the light carries on travelling fast, but on this side it's got to suddenly go slower, and so because of that it bends, it changes direction, and that is what refraction's about. And so the difference between the materials you have, if you've got a large difference between what they're made of, then you're going to have a larger refraction than if you've got a smaller difference. Waves change direction when they pass across the boundary between two substances. In physics we sometimes call this the media. So one object we might call the medium. So waves can travel through a medium, and if there's more than one medium then we have media. Waves travel, this causes them to change direction, and this effect is called refraction. When light enters a denser medium, it slows down. Its frequency stays the same, but its wavelength also decreases. So when light enters a different transparent medium, it will change direction. It bends towards the normal when travelling into a denser medium. So here we've got light that is travelling through air, it's hitting the boundary between the air and the water, and it is bending, it's changing direction, and it changes direction and it bends towards the normal. So the angle in the air is larger than the angle in the water. So we call that red line the incident ray and the blue line the refracted ray. So angle 1 is the incident angle and angle 2 is the refracted angle. Okay, so this is what you should be able to do by the end of this lesson. You should be able to describe that light changes direction when it enters different transparent media at an angle, and you should be able to explain why light changes direction when it does that. So why should a non-swimmer be careful about jumping into a pool of water that looks shallow? So in everyday life, we know that light travels in straight lines. We've just found out that when light hits the boundary between two different transparent media, then it changes direction. But we're not used to that. So if there's an object in some water, so it's at the bottom of a pool of water, our eye would think it's there because we think that the light travels in straight lines. So the image on the bottom of the pool appears shallower because in air light travels in straight lines. When we look into water, the light is bent because it is refracted. Okay, so that's been another physics video all about refraction. I've been Mr. Baker, and I'll see you next time. Thanks very much.